How are we going, people? Level 3 integration. Let's do a quick sound check, guys, and I think we should be alright. I forgot. Let's do a quick sound check, guys, and I think we should be alright. Hey, Marco. Missed you on Sunday. I think, was it on Sunday? What exam do you have on Thursday? Oh, jeez. M over X. Hey, Zoe. Now, I've got one question here. Looks like a proof question. Let me just have a look if there's any other integration questions that I haven't done from the past. Still got that other question that I need to do, which I haven't done yet. Video integration. What is this? 14 integration. No, that's different. Yeah, that's different. Hey H, how you going? Got any questions today? I'm just looking through my old question just to see if there's any that I've missed. Oh, gotta buy that as well. Level 3 integration mock question. What is this? Determine the value of A2 over A1. I'm gonna show you guys a question. It's pretty hard to kind of see the question. All right, let's see. Hopefully this question pops up. I mean, if it pops up, then we can kind of do this. So just giving it a couple of seconds to just sync up. If not, you guys can pick another question and then we can actually go through it. This is MBAS. I don't even know what that school is. Come on, man. How long does it take for this thing to sync up? Ah, here we go. Okay, hopefully you can see the question here. Negative k where x is k is greater than 0, y is equal to 0. Blah, blah, blah. Yeah, let's try this question here. So I'm not sure if you can see it properly, but I'm just going to kind of make some notes there. That's p, that's 2p, this is minus maybe a different pen. Is that gonna, no, that ain't gonna be better as well. Let's try this, p and 2p, and then we've got negative k, negative 2k. The graph is y equals to m over x, and this is a1 and this is a2, and they are asking for the ratio of a2 divided by a1. No, you're all good, Marco. What happened, Tech? Oh, you guys are doing the numeracy co-requisite. That's right. Yeah, I had to pull out some of my content for that. Lovely copyright. So guys, I'm gonna give you, what is it? What's the time? Where's my clock gone? Okay, let's chuck that up there. I'll give you guys a couple of minutes just to have a go at this, and then I'll go through the answer. All right. H, I'll have a look at your questions. Are they all integration questions, H? Yep, we've got a couple of questions that's come through. That's nice. Jeez, that's more than a couple. Herschel, if you could just send me the answers as well, please. If you don't have the answers, we're just gonna end up going around a goose chase. But although, mind you, that question there, that it's a proof question, so we should be okay with it. All right, so let's get started with this question. Or do you guys need a bit more time? Let me know. Do we need a bit more time to do this, or shall I start it? I'll start it at 8:07, right? Last level 3 complex numbers. Where did that question come from? Was this the one that we did? This one here. I don't know. Someone sent it to me. I can't remember where it came from. All right, so let's start doing this one. All right. So what we're going to do is we've got integral between 2p and p for m of mx. Now this is a2, and then a1 is equal to integral of negative 2k minus k m over x. Now the m is greater than 0, so we're not really going to worry too much about it. So a2 is equal to m ln of x, and that's between 2p and p. So I'm going to kind of work this out first. Am I missing anything here? M ln of x? No, that's basically it. So then a2 is equal to m ln of 2p minus m ln of p. So I could rewrite this as a2 is equal to ln of 2p to the power of m minus ln of p to the power of m, because remember how the powers actually come in front of the logs. Then I could do log divide, so a2 is equal to ln of 2pm divided by pm, and when I get that, a2 is equal to ln of 2. I'm worried about this. I could be completely wrong, but yeah, anyway, let's just see what happens if I do the other version for a1. I have no idea, Tech Gaming, because I think someone emailed it to me and I think we just started working on it. So next one, I've got m ln of x between minus k and minus 2k. So then a1 is equal to m ln of negative k. Here's where I'm going to get stuck. I feel it. Minus m ln of negative 2k. So I'm going to pretty much follow the same rule. So m ln, no, I'm going to get rid of the ln, negative k to the power of m. But this doesn't work. Because if k is greater than 0, how is this going to... Oh, but... I have a feeling I'm doing something incorrect here. I'm just going to keep going anyway. So a1 is equal to ln of negative k to the power of m divided by negative 2k to the power of m. Which means a1 is equal to ln of negative 1 over 2. So it's going to be positive 1 over 2. So then the ratio a1 over a2 is going to be ln of half divided by ln of 2. I'm thinking that's what it is. I have no idea. I have no idea, because the person that actually sent me this question, I hope if they had the answers that would have helped. I'm gonna try and see if I can respond to them. Who was this? J. There we go. What do you guys think? Have I messed up somewhere, or does this look good? Now that's the log rules, Ryan, because if you have, say, let me show you guys in the calculator to see if it kind of makes sense. So if I do 3 times ln of 2, it's the same thing as saying ln of 2 to the power of 3. So all I've done is, you know how this is m, so that m is going to go as the power of the 2. So in this case, I can actually move the m as a power. That's not the issue. I think I know where my problem is. ln of negative half. I feel like I've made a mistake with that negative 2km. I feel like that's where I've made a mistake. It doesn't look right. The negative 2km. Okay, give me 1 second. I just want to check something here. I know this just doesn't feel right. ln of negative 2k. They've actually got ln of half m. Where did they get that? Yeah, I'm not convinced with this step here, so I'm going to rewrite the step. Give me 1 second. I'm actually going to rewrite this from here as, I'm going to take m out as a common factor, which means I'm going to get ln of negative k minus ln of negative 2k. I think this might be better. Then I'm going to get ln of negative k divided by negative 2k. So m ln of negative half, and then a1 is equal to ln of negative half to the power of m. I think that's much better. I feel a lot more confident with that one. Yeah, that's the one, Ryan. Yeah, that's what I thought. Something looked a bit awkward with that negative 2km. All right, so I think I'm happy with that, unless I'm stuffed it up somewhere again, which is quite a possibility. Let's gonna go pick up a few more questions, guys. Give me a second. Who do we have? Oh, Jade. Right. The computer won't let me message chat. Oh, okay. If you're in the, I know you just sent me the question. I'm chatting to you on the email there, but I think this is what the answer is. I could be completely wrong, but that's all right. At least we had a go at this. The next question I wanted to try was this one here, because this was a proof question, and proof questions are always fun to do. It looks like another excellence question. So let me put this up, and we can try and have a go at this. going to be one of those annoying questions. But here it pops up, and I'm going to give you guys about 3 to 4 minutes to try and do this one. And I will actually work on this question on the side, or at least in my head. Or paper. I need paper. So what's the time right now? Let's say this is 8:16, so I'll go through this answer at 8:20. But that's okay. So all right. What do you got? Another 20 seconds. I think I've got it worked out. How are you guys going here? Now, if you're stuck with this question, folks, just remember, differentiate this function, put it equal to 0 to find out your turning points, and that should give you the limit for the area that you're going to be. The two limits, well, the first limit is obvious, it's 0, and you can figure out what the second limit is when you differentiate it. Shall I go through the answer, or do you guys need a bit more time? All right, super quiet today, so I'll just get going with the answer, all right? So the first thing I'm going to do is I want to actually figure out what this turning point here is, so the x value of that point. What it says is that point A is a maximum point of that curve, which means the gradient is equal to 0. So I could actually say that f of x is equal to x squared p minus x cubed. Then f dash of x is equal to 2xp minus 3x squared. Now I know that the gradient is equal to 0 for maximum, so I'm going to put f dash of x is equal to 0. So 0 is equal to 2xp minus 3x squared. X is a common factor, so I'm going to get 2p minus 3x. So here I can say that x is equal to 0, or 2p minus 3x equals to 0. So rearranging this, I'm going to get 2p equals to 3x, and x is equal to 2p over 3. So this x value here is 2p over 3. So I kind of needed to do this first to figure out my upper and lower limit for this area between these area under the curve for this. So I've got between 2p over 3 and 0 and x squared p minus x cubed dx. I'm just going to pause there and just to ask you guys if there's any questions so far with what I've done before carrying on with this. Give me a thumbs up or something to let me know this is all good before we can move on. Oh wow, they just chat just went kind of crazy. Yeah, so Tech Gaming Smart, so we use differentiation to find the points. Yes, we do, because we need to find out what the x values are before we can actually figure out what the area is, because we need the limits for the area, right? And we don't have that. We've got 0 as one of the value, but we've got to figure out that 2p over 3. Now, once we've got that, our next step is then to integrate. So when I integrate x squared, I'm going to get x cubed over p over 3 minus x to the power of 4 over 4, and that is for 2p over 3 and 0 as my limits. How do we know the maximum is 0, sir? EP, remember that when it's a maximum or minimum, the gradient is always equal to 0. So that's when turning points happen, when the gradient is equal to 0. So that's why I differentiated it and then put it equal to 0 to get my 2 turning points. So the gradient is basically 0 here and also here where it's at 0. So my next step is then to substitute 2p cubed into 2p over 3 into x cubed. So I'm going to get 2p over 3 to the power of 3 multiplied by p over 3 minus 2p over 3 to the power of 4 divided by 4. Now I don't have to worry about the 0 because when I substitute x as 0, I'm just going to completely ignore it because that's just going to be ending up as 0. So here I've got a whole lot of expanding that I need to I've got to get rid of those cubes and to the power of 4s, right? So 2 to the power of 3 first is 8. P to the power of 3 is 8p cubed divided by 3 to the power of 3, which is 27, times p over 3 minus, I've got 2 to the power of 4, which is 16. P to the power of 4 is p to the power of 4 divided by 3 to the power of 4, which is 81, and all of that is divided by 4. So the next step is I'm going to get 8p to the power of 4 divided by 27 times 3 minus 16p4 divided by 81 times 4. And the next step is, of course, I need to have the denominators as the same. So I've got 8p4 over 81 minus 16p4 over 81 times 4. Now I'm not really going to do that 81 times 4, partially because it doesn't really matter. I'm just going to leave it there, because what I am going to do though is I'm going to multiply this 81 by 4 and also the numerator with a 4. When I do this, I'm going to get 32p4 over 81 times 4 minus 16p4 divided by 81 times 4. Then, because they're all have the same denominator, I could write this as 32 minus 16 is 16p4 divided by 81 times 4. Now I can cancel out the 4 and the 16, and I can write this as 4p4 over 81, which is basically the answer that we've been given, or at least it's been asked to prove that. So what I'll do is, as always, I'll put up a couple of line numbers and let me know where, if there's any issues. 9, 10, 14, 15, 16, 17. That's actually quite a nice question there. Whoever that has sent it to me. Oh, jeez. It's actually sent me quite a few questions. Oh, he gave me the answers as well. Alright, I'm going to save that second one, kinematics one, for another one, because I've got a few more that's coming through. Any questions with that, folks? Or are we good with that? On to the next question for integration. You would flip it, fraction in a fraction, but remember, like something like this, right? So I'm looking at particularly this part here. Let's look at this yellow box. So if I was to do 16p4 over 81 divided by 4, then what I would do is the same thing as 16p4 over 81 times the reciprocal, which is 1 over 4. Therefore, I can write this as 16p4 divided by 81 times 4. And that's what I did in that second line there. So, and that's the same thing for that 3 as well. Alright guys, I'm going to pull up a differential equation question. Another excellence one. Love it. We've got a lot of excellence questions today. Oh, yep, cool. Tech smart, that's good. We will go to the next excellence question, which is actually a differential equation one, and hopefully it pops up. I love proof questions in calculus, right? Because it's just like you kind of work through a lot, and then finally it comes and it pops up, and you're like, yeah, that's satisfying to kind of get it done. All right, where is my next question? Come on, man, why does it take this long to sync? Here we go. Classic differential equation. I actually really love this question because this covers so many elements of integration. My recommendation for you guys, if you're going to attempt this question, is probably good to do substitution here. Just will help you. Otherwise, I'll tell you what, I'm going to give you guys about 3 to 4 minutes to try and give it a go. My only suggestion for this is you've got to actually split it correctly. Once you split it correctly, you're pretty much good to go after that. Integration, Grace. I think the previous question you had to differentiate to get the points before you could actually integrate the area. Now, if you're stuck with this one, I'm going to give you guys the starting point of this. Starting point of this question, I would recommend you to do something like this. Because you want to have all the y's on one side, I would actually do this. dy over y is equal to 8e2x 1 plus e to the power of 2x dx. So this is pretty much the first step that you want to be doing, and have a go from this point onwards. Now, if you're trying to figure out how to integrate that 1 plus e to the 2x part, substitution will work beautifully in this, or reverse chain rule, whichever one you choose. Give it a go there. Will this be 9y e to the power of 3x? No, Marco, because e to the, like when you integrate e to the power of 2x, nothing happens to the power, it just stays as it is. That's something special about exponential curves, is if you have e to the power of x and you differentiate it, you're going to end up still with e to the power of x. It's one of those weird things where the y value is almost, it goes at the same rate as the gradient itself. So yeah, I think you would have missed that part from differentiation, and that might be why you haven't got it yet. Anyway, so what we're going to do is, do we need a bit more time, folks, or are you ready for me to go through the answer? Yep, sure, one more minute. That's awesome to hear, folks, that you're kind of getting a nearly, so that's good. Alright guys, I'm going to start going through this. Don't worry, just keep working away. I'm sure by the time I finish this, you would have finished the question there. So, alright, so integration of 1 over y, that's fairly straightforward, because that one we can just write it as ln of y equals integration of this. Now, this one, I like using reverse chain rule, right? Because with reverse chain rule, I can kind of see that when I differentiate this, I'm going to get e to the power of 2x. Actually, no, when I differentiate that, I'm going to get 2e2x. So I know that way I can actually cancel out. So this is how reverse chain rule works, right? So reverse chain rule, I'd actually write down the numerator, which is 8e2x, ln of 1 plus e to the power of 2x, divided by the differentiation of this 1 plus e2x. Now the differentiation of that happens to be 2e2x. So basically what's happening is, of course, don't forget the plus c. The e2x cancels out. The 2 cancels out with the 8, and I'm left with 4. So what I've got is ln of y is equal to 4 ln of 1 plus e to the power of 2x plus c. So this is doing it through reverse chain rule. Now if you're doing it through substitution, you would do something like this: 8e2x divided by 1 plus e to the power of 2x dx. So you would actually put down u is equal to 1 plus e to the power of 2x, then du dx is equal to e to the power of 2x multiplied by the differentiation of 2x, which is 2. So then what you could do is you could actually say that 8 times e to the power of 2x, you could write it as 4 times 2e2x dx and 1 plus e to the power of 2x. Now 1 plus e to the power of 2x is equal to u, so this part is going to equal to u. I forgot one more step. The one other step that I'd have to do is du equals 2e2x dx. Now this entire part here is going to equal to 2, so this is pretty much this yellow part here that's going to equal du. So I could rewrite this whole equation as 4 over u du, and when I integrate this, I'm going to get 4 ln of u plus c, and because u is equal to 1 plus e to the power of 2x, I can do it this way there. So this is pretty much substitution. Right now you can do reverse chain rule like how I did in that first on the example on the left side, or you could actually do it through substitution as well. Now substitution is always going to be super clean, like everything kind of works out real nicely. Reverse chain rule, if you forget that, you know, there's a lot more opportunities for you to actually make mistakes with the reverse chain rule. All right, so we've got that now, and I guess the next step is we know that when x is equal to 0, y is equal to 4. So what we're going to do is we've got ln of 4. Reverse chain rule only works for like when it's when you do something like not reverse chain rule. What is it? It's not reverse chain rule could work, but there's also another one, like f dash of x. It's something like this. It's like integral of f dash of x of f of x is equal to ln of f of x plus c, something like that. You kind of see that one as well, but reverse chain rule kind of works. Reverse chain rule does. I think I might have said it wrong. I don't think this is reverse chain rule. I think it's this one here. But I prefer using substitution, right? Because it just works out clean. But anyway, let's get back here. So we've got ln of 4 equals 4 ln of 1 plus e to the power of 0 plus c. Ln of 4 is equal to 4 ln of e to the power of 0 is, what is e to the power of 0? It should be 1. So we're going to get 1 plus 1, which is 2 plus c. So ln of 4 is equal to ln of 2 to the power of 4 plus c. So c is equal to ln of 4 minus ln of 2 to the power of 4, which we can say that c is equal to ln of 4 divided by 2 to the power of 4. 4 divided by 2 to the power of 4 is, what is it? 2 to the power of 4 is 16, so it's 1 over 16. So c is equal to ln of 1 over 16. Now the question is actually asking find the value of x when y is equal to 9. So my equation is equal to ln of y equals 4 ln of 1 plus e to the power of 2x plus ln of 1 over 16. So ln of 9 is equal to 4 ln of 1 plus e to the power of 2x plus ln of 1 over 16. So with that case, if I rearrange this, I'm going to get ln of 9 minus ln of 1 over 16. is equal to 4 ln of 1 plus e to the power of 2x. Ln of 9 minus 16, I'm going to get ln of 9 divided by 1 over 16. So that's going to be 9 divided by 1 divided by 16 is, what have I done here? Let's just try this again. 9 divided by 1 divided by 16. Should have got 144, so I'm going to replace, actually no, I will leave that there. Ln of 9 divided by 1 over 16 equals 4 ln of 1 plus e to the power of 2x. Now I really want to get rid of that 4. Unfortunately, I don't think I can. So I'm going to get ln of 144 divided by 4 equals ln of 1 plus e to the power of 2x. So 1 plus e to the power of 2x is equal to e to the power of ln 144 divided by 4. E to the power of 2x is equal to e to the power of ln 144 divided by 4 minus 1. I think I've messed up somewhere. Yeah, Ryan, I think you can calculate it. In fact, I think I might have messed up somewhere. I get this feeling that I've messed up somewhere. I just want to see if I got the C value correct, because this should not get this complicated unless I messed up somewhere, which is quite possible. Let's just delete all of this. So first off, I've got ln of 4. Just want to check if I've done this right. Ln of 4 is equal to 4 times ln of 2 plus c. I've got negative 1.38. So C is negative 1.3863. I just want to check that first. Ln of 1 divided by 16. Now here's where the problem is. What did I make a mistake with here? Is it 1 over 16 or 1 over 8? 4 over 2 to the power of 4 is 16. Ah, here's my mistake. That should be ln of 4. So if I do ln of a quarter, that's better. So this is going to be 1 over 4. 1 over 4. That's going to be 1 over 4. That's going to be 1 over 4. This is going to be 36. Yeah, I think I'm going to try and do this. I think I am going to try and do it your way. Yeah, I think I messed up that 1 over 4. That's fine. What else could I do here? Well, actually, I could do this. Hang on a minute. Ln of 36 is equal to ln of 1 plus e to the power of 2x to the power of 4. Then I could say 36 is equal to 1 plus e to the power of 2x to the power of 4. Damn, the 36 is bugging me. The 4th root of 36. That won't work. What did you guys get? No, I don't think I have the answer there, Gracie. Let me just check. Do I have the answer? X is equal to, oh no, looks like I'm on the right track here. Yeah, no, I've got it, yeah. So I'm on the right track. So this is going to become 36 to the power of the fourth root of 36 is equal to 1 plus e to the power of 2x. And then e to the power of 2x is equal to fourth root of 36 minus 1. And 2x, so I take ln of both sides. So 2x is equal to ln of fourth root of 36 minus 1. And then finally, I was on the right track, but I was just surprised that they gave such an ugly number to finish with. So that's what you should have got. I think which is 0.1856 if I work it out. So fourth root of 36 minus 1, that's going to give me that. ln of answer is going to give me this. Divided by 2 is going to give me 0.1856. Yeah, that's what we've got here as well, Ryan. That's, oh man, that was I made that quarter mistake. I think I made that quarter mistake, and that basically just messed me up. But see, this is the frustrating thing with these questions, right? Like, the reason I was trying to do this without a calculator was because I know that these numbers should work out real nicely, but unfortunately not in this case, because they've just decided to go with a crazy number, which kind of sucks. Skip ads. Cool, so let me put some line numbers. I mean, do I need to put line numbers, or do you guys think how come we need to use log properties? You have to. Log properties are something that you guys learn in level 2, and so it's automatically assumed that you will know them for level 3. I'm just gonna have a look. I don't think they give you log formulas in level 3 calculus formula sheet, do they? Oh no, they do give the formula. Sorry, my mistake. Here we go. So they actually give you guys all the log rules here. So if I do log x minus log y, I can write it as log x over y. I've got the n log x as well. So if the n is in the front, you can bring it to the power up. So you can actually put x to the power of n. So log rules are available for you guys in the formula sheet. So, and I think that's why you kind of have to use it to try and solve this. Any other question, guys? I don't understand the last 5 lines. Abhi, are you talking about basically from here? Sorry. Are you talking below the red line? Is that what you're having challenges with? Sorry, Musical Gamer, I've missed all of your comments there. Could you just differentiate the first equation? What? I'm doing integration here. Okay, so Abhi, what we have is from this step here, I actually want to get rid of the 4. If I want to get rid of the 4, I've got to multiply the powers by a quarter. And so that's what I did. So I'm going to get 36 to the power of a quarter equals 1 plus e to the power of 2x. Now 36 to the power of a quarter could be written as the fourth root of 36 to the power of 1. So I've just not written the 1, instead of writing the 1, I just left it as is. And then I've written it as 1 plus e to the power of 2x. Next, I went 4 root 36 minus 1 equals e to the power of 2x. Now I want to have x by itself, so I took logs of both sides. So 36 minus 1, and then if I take log and exponential, cancel out. So I'm left with just 2x. Then I can say that x is equal to ln of the fourth root of 36 minus 1 divided by 2. It's just doing a couple of extra steps there. Very nice. Inversely proportional to money squared. So wouldn't that just be like 1 over m squared? At least that's what I'm thinking. Tech Gaming Nav, I'm on some very strong medication and I think my headache is not going away. I've literally been having non-stop headaches for the last 2 days and it's just been super annoying. But I did see the doctor today and got some meds, and hopefully I'll get a referral and in this public system, which means it'll be sometime next year, and by that time whatever I had is probably either deteriorated or gone for good, and I'm hoping that it actually goes for good. I think if it's inversely proportion, then where's my notes from like 20? Hang on a second. I had my notes. Applications, particular solutions. Is it this one? I'm just having a look. Give me 1 second, Applications. That's all right. Proportional to the quantity itself. Separate the variables. Where's the inversely proportional? I had it in one of my notes. Okay, here we go. So, formation of differential equations is the one you want to have a look at, Musical Gamer. Pretty much go through the rules on what happens with each of the situations that you could potentially have. So it's under the level 3 integration playlist and it's called Formation of Differential Equations, and if you go there, that should help you out with that. No worries. All right, next question. Let me just have a look. I think we've got time for one more. Right. 2013 2D. Wait, that's a Ryan. Oh, 1E. Okay, let me just have a look, Ryan. Oh, Ryan, that question is like ridiculously easy, which it's all to do with substitution. That's all. I know it looks complicated, but in reality, it's literally a straightforward substitution question, and it's not going to take you that long. Are you sure you want me to go through that? I mean, I don't mind, but 2013, I remember that. 579. Okay, cool. Let's actually do the 2013 1E1, and then I will probably call it after that, guys. So we've got a few questions for the next time. So I'll copy this. Don't know why this question always takes. The syncing has been a bit rubbish this today. Sync this notebook now. All right, so this is from 2013, the question 1E, I think it was. So I don't like the energy pumped in, cross-sectional area. So I'll do the cylindrical tank first, right? Like if you look at the cylindrical tank, what we're going to have is KH. Let me just grab this. So doing the cylindrical tank first, we've got the energy is equal to H and 0. Nothing really to do with that. K is just a constant. We're not going to do anything with this. H minus H, capital H is the height, so that's a number. H minus H, and then we've got area of H dH. Now area of H is the surface area at this instant, right? Now if you look at the cylinder, that is basically just pi r squared, because that's a circle. So we're going to get E is equal to H0 K H minus H pi capital R squared dH. Now the R is also a constant because, you know, it's not really changing. So then we could say that we're going to get, if I was to expand this, I am going to get K pi R squared H minus K pi R squared H, like this. So remember that this is actually a constant. The H is actually a constant, right? But the little h is the one that's actually changing. That's why they have it as dH. So when we integrate this, we're going to get E is equal to K pi R squared H is all constants, which means I'm going to get H minus K pi R squared is also a constant, but I'm going to get H squared over 2. And all of this is between H and 0. So with that in mind, I can then say E is equal to K pi R squared H. The little green h has got to be substituted as H minus K pi R squared H squared over 2. The 0, I'm not really going to worry about it. So E is equal to, this is going to become H squared. So this is 2 over 2. So I'm going to end up with just K pi R squared H squared over 2. So let me just do that 2 and 2 again. So that's going to be 2 and 2. That's H squared. H and H is H squared. Let me know if that's okay for the cylindrical tank. Now once you get the cylindrical tank, now next one you've got to do is the cone. So once again we're going to do the same thing with the cone. So we're going to go E is H0 K H minus H area A of H dH. Now here is the problem. The problem with the cone is that depending on what the height is, the radius is actually going to change. Because if you think about it, if the height of the water is here, then the radius is actually a lot smaller. Now, that's not the case with the cylinder. The cylinder, regardless of where the height is, the radius is always still going to be the same. But with the cone, the radius is actually changing. So what we have there is we've got a similar triangle that we need to kind of work out. So we got capital H, we've got big R, and let's say this is from here to here is the actual height, then this is going to be the radius for that circle that's actually inside the cone. So when we think about radius, that little r, we have to write it. So we have to actually put the little r in there, but the way we're going to put it is little r divided by h is equal to capital R divided by capital H. So little radius is equal to capital R times H over H. So the thing that's changing again is just the H that's going to be changing. Adiba, are you actually talking about the 15-hour playlist? I haven't done that for differentiation or integration, sorry. Never got a chance to get around to it. So with that in mind, we're going to follow the same process again. We've got h and 0, k, h minus h, and instead of pi capital R squared, we're going to put the little r, and because it's little r, we're going to put that as r h over h squared dh. Okay, all it is like in this question, all you're doing is just a bunch of substitutions. So then we're going to get E is equal to H0, K times H minus H, pi R squared, H squared over H squared, dH. So now we're going to actually expand the brackets. And when we expand the brackets, we are going to get K pi R squared H squared times H over H squared minus, we're going to have a whole bunch of H squared here, isn't it? I'm going to get annoyed with this. Then we got K pi R squared H squared over H squared multiplied by H. So all I've done is I've just expanded the brackets there. But I feel like I've missed something. No, h squared, that's all looking good. So now I can actually integrate this, but for me to integrate this, I'm integrating just these values here. So that's actually h cubed there. So I'm going to end up with E is equal to, let's actually do this, K pi R squared H over H squared times H cubed over 3 minus K pi R squared over H squared. Now that was H cubed, so this is going to be H4 over 4. And all of this is between H and 0. Stupidly annoying question, but this is what we have to deal with. So K pi R squared H, I'm going to substitute the little h with the big H, so that's going to become H3 over 3H squared minus K pi R squared H4 divided by 4H squared. Don't have to worry about the 0, so then E is equal to, I've got H4 in the numerator, H squared, so this is going to become K pi R squared H squared minus K pi R squared H squared over 4, which means I'm going to get 3/4, or I've made a mistake somewhere. Three and 4 I should have got. Oh, I forgot the 3. There we go. That's better. Now what I've got is, I've actually got E is equal to K pi R squared H squared, and in the bracket I've got 1/3 take away 1/4. which I'm gonna be super lazy and just gonna do this in the calculator. So 1 over 3, take away 1 over 4 is gonna give me 1 over 12. So E is equal to K pi R squared H squared 1 over 12. Now if you look at the question itself, it says show that the conical tank is 1/6 the energy required for the cylindrical tank. So if you actually take 1/6 of the cylinder, 1/6 times K pi R squared H squared over 2, which is from here, equals 1 over 12 K pi R squared H squared, which is what we got here. Yeah, so it's one of those questions where it's like, you know, it's just a lot of substitution in it, and the fact that they've got like capital H and little h, it can get confusing. But if you just, you know, I remember seeing this question and my kids came when I was teaching that year. I had a bunch of kids that came and said to me, "Oh, that question was really hard," and I'm like, "Well, actually, it's just a bunch of substitution." Yeah, tech gaming. The capital H is that's the height of the cylinder, right? But the little h is the water as it's actually filling up the cylinder and the cone. Now with the cylinder, the radius is not going to change, because when you pour water inside a cylinder, the surface area of that circle is always going to be constant going up, right? But if you do it at a cone, then what happens is when you fill water in a cone, at the bottom it's almost non-existent, and then slowly the circle actually expands and the circle just gets bigger and bigger and bigger. So that's why you kind of need to rewrite the radius, the capital R. We need to do this part here. So we need to do that to try and offset, like to kind of show that the radius changes as the height changes for the water. Yeah, well, anyway guys, that is basically it for today. Hopefully you know, that was what we did, about 4 excellence questions. 1, 2, 3, 4 excellence questions today. That's actually not bad. Good excellence, good variety of questions actually. So thank you for sending them in today. Which school is that? Musical? Oh, St. Peter's, Palmy. Nice, very nice. You know, I actually wanted to show you guys, I was kind of messing around with this stuff the other day. Found out, trying to look at like subscriber milestone. So supposedly I'm supposed to get this what is it, the silver award on the 22nd of November 2024, and I'm gonna be honest, I don't think that's gonna happen, because normally what happens is like there's this big dip for the next 6 months where there's hardly any subs. So I predict, my prediction of this prediction is actually incorrect. Of course there's gonna be a hell of a lot of guys that are gonna be saying bye bye as well, which is gonna be sad, but that's the nature of the game. Oh, glad as well, Grace. Which school is that from? Well, I think the level ones, they're going to change, right? Because they might not have the MCAT, and if they don't have the MCAT, I don't know how it's going to work. Oh, Sancta, you're so close as well. You're just next door to me. Yeah, so according to my prediction is like back to 2026 or 2025, I'd almost say, before I ever hit 100K. Who's your teacher, Ryan? Musical, I'm based in Auckland. Like, Ryan actually studies in the school opposite me. Grace Sancta Maria, so it's about like 5 minutes drive from my school. So based in Auckland. Oh, he's a good man. Give him. Oh no, you guys are finished now, eh, Ryan? I forgot. Wait, I need to sing. Grace, did she used to teach at Manariva? Is she a calculus teacher? Tech gaming. I know those. The school of crosses already had a break. Wait, I gotta ask Grace. Grace, is this your current calculus teacher? Wow. I mean, so wait, so she's been recommending my channel, which is fine. What a small world. Ask her if she used to teach at Manariwa or not. Ah, Mr. Ardern is still there as well, of course. Let me have a look. I'm spying through your what can I do through department, man? Oh yeah, it is her. Yeah, now I know her. Grace, yeah, I kind of helped them out. Well, we kind of did some work together way back a while ago. Oh, musical gamer star program is brilliant. I remember that. That's a lot of work, man. Like, seriously, I have so much respect for the guys that do star program. Yeah, well, look, do say hi to her from me, because I started at the same time. What is it? I started teaching there. That was my first year in Manurewa High School. So small world, small world. Uh, anyway, guys, look, I'm gonna go get some shut eye right now. So good luck. I think, when am I seeing you next? When am I seeing you next? Oh wow, the next time I see you guys is the time before your exams. Jeez, that's a while away. I did talk to Tech Gaming. I think we might actually do that one excellence question a night leading up to the exams, because otherwise it's just too late. Otherwise, this is the last time I'm seeing you, which kind of sucks. Nah, Marco, I'm all good with just silver. Yeah, I've got a live on the 9th, but I think you guys have the. Oh, that's right. No, your guys' exam is on the 13th. Sorry, I forgot. I was like literally looking here, and then I forgot about the 12th. Okay, so we can actually do some work during that time. That's not a problem. That actually works out quite nice. Yeah, now we'll do the Tech Gaming has been asking for like doing excellence questions after my other streams are finished, so around 9:15, 9:30. So we might actually continue that starting tomorrow, right? So one question a night. Hopefully I can power through them, and then we should be fine. Oh man, cramming before that, like, I tell you what, it's crazy trying to do a stream before the night of the exam, because you get a whole bunch of people that just show up for the first time and they're like, teach me everything, and I'm like, oh really? Like, geez, that's just taken me like this long to try and get, like, takes such a long time to understand calc, right? And they're like, oh, what is differentiation of ln? Anyway, guys, look, have a good night, and I'll see you guys tomorrow night at about 9:15, 9:30, and I think we'll be doing the differentiation one. So somebody did send me a differentiation question, so we'll pick that up and then go through that during the tomorrow's tute late in the night. All right, take care. Till then, good luck. Catch you later.